All right, hello again. In this video, I'm going to talk about while loops, which is going to be the sort of other kind of common loop that we'll use in Python. They're not as common as for loops, but it's worth sort of being experienced in them because they show up in other languages and they can be useful for a couple particular circumstances. This video is again going to mostly repeat stuff that's in the course text, but again, it's very helpful to sort of see a demonstration of it actually working. So I'm going to record a video about it. All right, let's get going. So a while loop is going to be similar to a for loop, and it's going to be used to do something over and over and over again. But in particular, a while loop is used to execute a block repeatedly until the program reaches a certain state. So until something happens that causes it to stop, effectively. So the general syntax is that you're going to use because it's called a while loop because the keyword we're going to use is while, similar to how we use a for loops. And then we're going to put in the condition, which is going to be similar to a condition in an if statement. It's going to just be a Boolean expression, something that's going to resolve to either true or false. The way that the interpreter works is that it's going to say while, the interpreter, when it gets to a while statement, it'll look at that while, it'll say if this condition is true, then it'll execute that loop. It'll do this block of code. It'll then swing back around to the top, look at the condition. If that condition is still true, it'll do the loop again, swing back around to the top. If it's still true, swing back around and keep going. And then eventually, when it gets to the top and if that condition is false, then it'll say, I'm done. I no longer need to loop, so it'll stop doing that kind of work. Okay, so in particular, so again, the structures, we use a while loop, we use a colon and a block indentation, and that's where we get our structure. Often, if we want to do sort of counting type things, which is what our demo is going to be, which I'm going to get away from in a second, but we often have we might have a variable that would be our loop control variable. It's basically going to keep track of whether we should be looping or not. We have our condition, our check, we can do our work, we can then update our variables, right? Make sure our count repeats and do repeat in order to have this stuff work together. So let's look at this example sort of in practice to sort of clarify how this works. All right, so here's our example. So I'm going to find myself a count of 5, and I'm going to say while my count is greater than 0, so it basically will loop if my count is positive, I'll then do some work and then modify my count and then go back again. So we start with count as 5. 5 is in fact greater than 0, so we're going to print out the 5. We're then going to take my count and assign it to be a new value of 5 minus 1, so count is now 4. We then loop back to the top. 4 is greater than 0, so we're going to do it again. Count becomes 3. We loop back to the top. 3 is greater than 0. Do it again, etc. Until eventually count becomes 0. We get back to the top. 0 is not greater than 0 because they're the same thing. So therefore, we don't go back into the while loop. We print out blast off instead. So if we execute this code, we get 5, 4, 3, 2, 1, blast off. This is the exact same thing we could have done with a for loop, particularly with a range. While loops are usually not great when you have what's called definitive iteration, but at least I want to sort of show you sort of like what that process looks like in a way that's easy to sort of track how these things are going. Great, so that's the basic kind of idea. Important things to note about while loops. While loops only check the condition at the very beginning of a cycle. So if my count, for example, if I had count became 0 right here. How about, let's keep track of the old count. Could be the count. If I had my count became 0, and then I had my count then becomes the old count minus 1, so I keep it together. Even though count is being assigned 0 at this line of code, so that when I print out the count, it is in fact 0, because I then put back the old value, I put back the 4 instead, we're going to swing back around so that when we get back to the top, that's when it's going to check to see if count is 0. It doesn't matter if the condition becomes false somewhere in the middle of the block. We're only checking it sort of at the start of each cycle as we go through. Great. So while loops syntactically they feel like they're fairly straightforward. They're going to work similar, basically sort of a combination of a for loop and that they do that looping thing, and then a if statement, and then they're going to do some condition work. While loops and if, let me make this bigger so I can make sure you notice. While loops and if statements are different. An if statement lets you see if something's true once, and then if so, execute one line of code. A while loop says that we're going to check to see if that thing is true, and if so, we're going to do something over and over and over and over again. So if you want to do something repeatedly over and over and over again, you use a while loop, or for loop potentially. If you want to just see if something is true to make one single decision once and then move on with your life and never come back again, you're going to use an if statement. In practice, if statements are much, much more common than while loops. So if your gut was, I need to check if something's true or not, I need a condition, your default should be go with an if statement, don't go with a while loop. If statements are the right thing to go. While loops are rare, which is why they're their own so special video to sort of show off a couple examples of things. Okay, so when we're dealing with while loops, the syntax is not too terrible, but the issues with actually writing an effective while loop get really tricky because there's lots and lots of things that can go wrong. And so I'm going to basically, for the rest of the video, show you things that can go wrong with while loops and how we can try to fix them. All right, here's my first example. So my count is 0. I'm going to see while my count is equal to 100, I'm going to print my count and then see my count is equal to count plus 1, right? So the idea is I want to try to count up to 100. That's my goal here. If I execute this block of code, I hit shift return, nothing happens. It didn't actually print anything out. Why? Well, my count was started at 0, so I then check to see, I get my while loop. It says, great, I'm going to compare count to 100. Is 0 equal to 100? Nope. So therefore, my condition was false, so we never even went inside the loop. We just got to the end, and we could print out that we are now all done. So again, we see what's happening at the end of the loop. Right? So we're all done. We never printed anything out because we never got into the loop. And it's quite possible to say get to a statement and say, great, here's a while loop, and you never need to loop because we were never in a position where we had to cycle around. What this means is that when you're using while loops, you don't want to be thinking about what is my ending condition. I don't want to be thinking about loop until I get to 100. We want to be thinking about when should we keep going. I want to keep going while my count is not yet at 100. That's the things we want to try to avoid. Okay, so we might say, okay, I want to make sure I'm loop while I'm not yet at 100. So we might say, okay, let's make that change then. What happens if we do a count while not at 100? Okay, so our count becomes 0. This is going to work out okay. I'm going to actually make it not 100. Maybe let's make it 10 so we don't totally overload everything. So I might say, great, let's see if my counter is going to be, while we're not great up to 10, my count will increase by 1, and we can print out I'm all done. If I run this code, this works great, right? We printed out the numbers up 0 through 10, 9, just like we expected, right? I didn't get to 10, so I'm good to go. You want to be a little bit careful about this, though, because if, when using not equals to, because this is currently counting from 0 to 10, but what happens if my count was going up by 3s, so just as a variation? So in this case, my count would start at 0. I'm going to print out the 0. My count is going to go up to 3, so I'll loop back around, print out the 3, right, because my 3 is not 10, so I'm going to print out the count. My 3 goes up to 6. 6 is not 10, print out the count. My count goes up to 9. Count 9 is not 10, print out the count. My count goes up to 12. 12 is not 10, I print out the count, and then I'm going to keep going. And it will never actually ever stop. I will demonstrate this to you so that you never have to see it in action. All right, we're ready? We're going to run this. Go. And then it keeps going, and it's printing out those numbers, and it's printing out numbers, and it's printing out numbers, and you can see how long the scroll bar is, and it's printing out numbers, and it keeps going, and it's never, ever stopping. This is an example of what is called an infinite loop, because it's a loop that will go on for infinity. It will never end. Infinite loops are the bug that you hit when you're writing loops. They don't happen with for loops, because for loops do definite iteration usually, unless you screw something up really badly. But while loops, you can often hit this infinite loop, and effectively your program will stall, and it'll crash, and your computer will seem to explode, and your fan's going to kick in, because it's going to basically just be trying to calculate stuff over and over and over again, and the whole thing falls apart. In order to stop this, in Jupyter, if you hit an infinite loop, like I've hit before, we need to make sure to stop the interpreter. So we're going to go to our kernel menu, and I'm going to hit the interrupt button. And that's effectively like hitting Control-C right, on the command line. That's going to say, stop this thing, don't do any more work. It's now no longer printing my value. I get an error. You can actually see, oh my gosh, I lost it. You can see sort of an error at the end. If I scroll down far, I don't even know how far it goes. Stuff's way too far down. We're not going to look at it. Let's restart. So if you interrupt your kernel or you restart your kernel, that will let you sort of get out of an infinite loop so you can go back and try to fix your bug to be able to make these things happen. All right, so this is a little bit of a contrived example, but the general line here is that when we're looking at while loops, the condition should be where we loop, when should we, the condition is, should I keep going? And then in general, if I'm doing with numeric values, my should I keep going should use an inequality, right? I should keep going while my count is less than 100. Not that we're saying we're equaling 100, but we're saying like while we're less than 100, if we're in that sort of range of condition, that's when I want to keep going. If I do that work, that will then print out all my values up to 100, and then I become all done, and life keeps going. When using while loop for doing this kind of counting work, you need to be really careful. If I, for example, initialize my count, if I, for example, forget the count, I say, great, I'm just trying to write my while loop. While my count is less than 100, print out count. Let's restart our kernel, make sure you can see this all from the beginning. I execute this block of code. I'm going to immediately get a name error, which says that count's not defined because I'm trying to compare count to 100. It says, what is count? Count doesn't exist. I'm like, oh, right. Count doesn't exist. I better define it. Count is 0. Great. My count now exists. I should do my loop. And I hit go. And oh, crap. Now it's just printing out 0. And again, you see the infinite scrolling. And I've once again hit the infinite loop. This is with a while loop. If you have this loop, but you have this loop control variable like a counter, and you don't actually ever increase or change that counter, your loop is going to just keep going, and again, you're going to hit the infinite loop, and everything's going to fall apart. Interrupt, output, and so forth. So we really want to make sure that we are always going to include something like a counter, loop, some adjustment to our loop control variable at the end of the loop. What this generally means is that if you're trying to do something repeatedly and you want to do for like a count number of times, for loops are going to produce a better result, right? Because I could get this exact same issue by saying for count in range from 0 to 100, print my count, and now I don't have to deal with any count plus 1, I don't have to deal with infinite loop stuff, I know it's going to work out perfectly. So generally, using a for loop for anything that's what's called definite iteration, where you know, like, I want to do this 100 times, or I want to count up to a particular set of values, is going to work better and do that kind of work. Okay. The main line here, let me see if I can pull up my slides to do this. Go wrongs. The main line here is that while loops are used for what's called indefinite iteration. It's if you don't know how many times we're going to go through the loop. So when we have our count here, when I was trying to count that I want to count up to 100, I know that I'm going to go through that loop 100 times. Even if that count up to like my number, even if the my number is a variable, when the interpreter gets to that loop, it can look at that variable and say, okay, that variable tells me how many times I'm going to go through this loop. If you know how many times you're going to be going through that loop, like you're doing counting, or you're working with a list, or you're working with something that has a known sort of finite quantity, sort of known quantity, you want to use a for loop. And that's going to be what we're going to use most of the time, because most of the time we're trying not to deal with ambiguity, we're just going to be sort of looping through as we go. While loops are on the other hand used for indefinite iterations. If you don't know how many times you're going through the loop. So it's going to be like, I might go through this loop 4 times, 8 times, 12 times, 0 times, 36 times. I don't know how many times I'm going to go through the loop until I'm sort of in the middle of in that process. And if we're in that case, then we might use a while loop. So as an example of this, I'm going to paste in, I'm just going to paste in the example. I almost forget stalling things. So this is an example of flipping a coin until it shows up heads. So what I'm going to do is I'm going to flip a coin by picking a number. I need to import random. Don't forget that. Import random, because we're using random. I'm going to flip a coin by randomly picking a number between 0 or 1. So we'll call 0 heads, 1 tails. So I'm going to flip a coin by picking a random number. If my flip is 0, then I'm going to call it my flip is heads. Otherwise, I'm going to call my flip tails. I will print out what that flip is. And then the idea is that I want to keep flipping until I get heads. But I don't know how many times that's going to take. It might be 1 flip, right? I might flip the coin once, get heads, and be done. It might take me 20 flips. I might get tails repeatedly over and over again until eventually I get heads. It's on average going to be like 2 or 1.5 because that's how statistics works, but I don't know ahead of time. So in order to make this work, I'm going to define myself a variable that's going to keep track of whether or not I should continue looping, I should continue flipping. This is my should I keep going variable. So my can I keep going variable, I'm going to call still flipping, and I'm going to assign a value of true to that. And then I can have this nice line of code that says while I'm still flipping, keep flipping, right? And if I'm not still flipping, it'd be while I'm not still flipping. That'd be false. So if I'm still flipping, while I'm still flipping, then I'm going to flip my coin. I'm going to do my flipping work. Then I'm going to check to see if I should stop. So here's if my flip is heads, then my still flipping example is going to become, my still flipping tracker, my loop control variable will become false. So now I can then say that when I get back to the top of this loop, I'll say while still flipping, it says like, hey, are you still flipping? And the answer is no, I'm not. So therefore I'll be able to stop that kind of work. I will not continue looping. And so I can get to my all done. So we can execute this block of code, and you can see that we ran through once. It flipped tails, so that I had to go through. So because my flip was not heads, I was still going. So I went through and did it again, and then I got heads, and that was all done because I stopped at heads. If I run it again, I get the same result. If I run it again, in this case, it took me 2 times through tails before I got heads. This time it only took me 1 time through heads before I got tails. 1 time flipping before I got heads. 2. Let's see if I can get something really long. I'll do this for about 1 more second. No, I'm getting a lot of heads. I'm being very lucky. Sometimes in this example I can get to run really, really long. but it's a video, so who knows? Of course, it's not going to break out. Whatever. We're getting about the same kind of effect. So again, I don't know how many times we're getting through the flipping, so therefore, because I don't know how many times I'm going to do this, I'm going to end up using something like a while loop. While loops are good for if you don't know what's happening, if there's something random or unexpected. So things like using the random function often means you might be using while loops. If you're using things like user input, there might be while loops because who knows what users are going to provide as input. But in general, if you're dealing with lists, if we're dealing with sort of the kinds of structures we're mostly going to be using in Python, you want to use a for loop. But while loops are good for doing this kind of like indefinite iteration type work. Piece of vocabulary to note, this variable here, this loop control variable, is often referred to as a sentinel, like a guard. It's going to basically say, should I stay in the loop or not? So while the guard is true, right, while we're locked in, we're going to keep looping. If the guard becomes false, that basically says, great, open up, and we're able to then keep going and be able to get out of things as well. Great. But yeah, so that's the basic idea of a while loop. We use them occasionally for some things. They're not going to show up super often in this class, but I wanted to at least introduce them to you so at least you had seen these things before, and so you understood the concept of both an infinite loop, because those kind of things might show up, and it's good to know that in terms of doing computer programming, and because how while loops work. The other important thing to note, slide thing up here, is that all iteration, all for loops can actually be written as a while loop. You can't go the other way. It's possible that, for example, I can't do that flipping thing as a for loop cleanly or at all. But any counting for loop I can do as a while loop. So technically the while loop is the simpler, more basic kind of loop, but the for loop is cleaner and easier, so we're going to tend to use for loops more often as we're writing our code. Great, and that should more or less cover loops. Again, if there's any questions, please just let us know.